Okay, so this video is meant to show you guys how to solve multi-step equations for stoichiometry. Hopefully by now you've struggled with this a little bit, you've practiced a little bit, but I want to give a formal video for people who are still struggling. So I'm going to show three different methods. I'm going to show step-by-step method, a traditional method, and combining step methods. My preferred method that I like to use is combining steps, but I want to show you the step-by-step method first, because without that, the combining steps method, you're going to make some silly mistakes. It's really the easiest. I think the step-by-step is the easiest to understand, but it looks like a lot of work. Really, all of these methods use the same amount of work. It's more a matter of like how you write it down. And these are not by any stretch of the imagination the only ways to solve these questions. All right, so very first, we need to remember the heart of stoichiometry, the mole ratio. Every stoichiometry question where you're changing one substance into another substance uses this. Right? So first you want to read the question. How many moles of ammonia, NH3, will be produced when 12.8 moles of hydrogen are consumed with excess nitrogen according to the reaction below? So pay attention to what the question means, but when it comes to the math isn't going to care so much about what it means. It's going to really, the math is always the same. So when we look at this, we're going to take our given value, 12.8 moles of hydrogen. So and we're going to write that here. And we're going to decide, what do I want to find? So it says how many moles of ammonia. So I'm going to find moles of ammonia when I'm done. Okay. So when I do this, I'm basically, mathematically what I'm doing is I'm converting, quote unquote, hydrogen into ammonia. Well, hydrogen can't magically turn into ammonia. There has to be a chemical reaction that allows that to happen. So this is a magical chemical reaction that allows that to happen. This says that 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia, which is why the question is written out the way it is. We're producing ammonia, but we need hydrogen and nitrogen to do that, which is why this gives us this weird excess nitrogen thing, because if there's no nitrogen, the reaction wouldn't take place at all. So we're going to take this reaction and we're going to use it. This is our recipe. This is how this reaction happens in what ratios. So we're going to use that ratio and we're going to convert, quote unquote, hydrogen into ammonia. I'm always going to take my given value and I'm going to start with that. And then I'm going to use my mole ratio, and I'm going to multiply these two numbers together so that I cancel off the unit that I have. Notice I have moles of hydrogen here, so I want moles of hydrogen to cancel it off. And what I want to find, I'm going to put on top. So in this case, I want to find moles of NH3. This ratio is going to come from this chemical reaction. It takes 2 moles of ammonia are produced when 3 moles of hydrogen are consumed. So I'm just going to put those values in. So 2 moles of ammonia are produced when 3 moles of hydrogen are used. Notice again, my moles of hydrogen get canceled off, and I'm left with moles of ammonia in my question. So on my calculator, I'm literally going to do 12.8 times 2 divided by 3. So I'm going to do 12.8 times 2 divided by 3. And I'm going to get 5.33. Well, that is really strange. My calculator gives me a repeating value. It's 8.53. Moles of ammonia. So since I have the unit that I'm looking for and the substance that I'm looking for, I've solved the equation. Again, notice how from one substance to another substance, I'm going to use the chemical equation. And very importantly, I wrote these units moles because these are moles. They could be molecules. In some instances, they can be liters, but only under very strict circumstances. Typically, these are moles or atoms or molecules. In this case, it would be all molecules or moles. So let's try a very similar question to check my work and to do the work in a different way. Notice the difference between this question and the next question. In this case, it looks the same, but if you look at what I'm given and what I'm asking to find, my given is 12.8 grams of hydrogen, and I'm asked to find the mass of ammonia. The mass is in grams. Okay. So I can't quite use this idea. This is here's a common mistake that students will make. They'll write out their given. We're going to take 12 grams of a hydrogen, just like we started out before. And then they're going to write out, oh, I'm going to do the same thing. So I'm going to take 3 hydrogen and 2 ammonia. The problem with this is without writing your units, that looks correct. But when I write in my proper units from the chemical reaction, remember these mean moles. So moles and moles, that does not cancel off. That does not work. So my difficulty then is I need to use this to cancel off and to change my substances, but I can't yet because my units don't match. The heart of what I try to get my students to understand is you just need to make your units match. When you can make your units match and do it properly mathematically, then you can solve this question. So, the step-by-step method. Here's what we're going to do. Here's how we're going to solve that issue. I'm going to, knowing that I need to use this ratio and that this is in moles, I'm going to first change 12.8 grams of H2 into moles of H2. And then I'm going to take those moles of H2, and now because they're in moles, I can change it to a different substance, to moles of NH3, but that's not going to be my final answer because that's in moles, but I can go to the periodic table and change moles of NH3 to grams of NH3. So this becomes a 3-step question, which it's no new work. It's not any new work. It's just stepping it out. It's taking one step at a time. So this first step is going to change grams of hydrogen to moles of hydrogen. So I'm going to go to my periodic table, and I'm going to take, there's 2.02 grams of hydrogen to 1 mole of hydrogen. Again, this is from the periodic table. I'm going to take and put that in my calculator. So it's 12.8 times 1 divided by 2.02. I don't really do need to do times 1, so I'm literally just going to do 12.8 divided by 2.02. And I'm going to get this weird, I don't like this calculator, I'm going to get 6.36666. So I'm not really rounding yet. I don't really care about my final answer right now. This is not my final answer, but this is moles of hydrogen. I'm going to take this answer, and that's going to be my given for step 2. So 6.34 moles of hydrogen. And now step 2 is I'm going to change moles of hydrogen to moles of ammonia. So I'm going to go to my chemical equation. 3 moles of hydrogen will be used up with every 2 moles of ammonia. So this is like the one step. This is my mole ratio. Okay, so again, my moles cancel off. I'm going to end up with moles of NH3. I'm going to go to my calculator. I'm going to take this answer. I'm going to try and keep all of my decimal places there. So I'm literally just going to hit now times 2 divided by 3. If you retype that number in, that's not the end of the world, but you're going to have a little bit of a rounding error. So you're going to have 4.22, maybe 4.23, depending if you rounded or not. But that's how many moles of ammonia are going to be produced. But now I need to change that to grams of ammonia, so I'm going to use my periodic table again. 4.22 moles of NH3. Going to turn that into grams of ammonia, so take 17 from the periodic table, add everything up. You should get 17.04 moles of nitrogen of ammonia to every 1 mole of ammonia. Remember, from the periodic table, you always have 1 mole of that substance. That's what the periodic table tells us. And we're going to do 4.2244, blah, 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 blah. This number times 17.044, 0.04, excuse me, divided by 1. And I'm going to get my answer to be 71.98. Really, I should probably round that up to 72. 72.0 if I'm going to do 3 sig figs, but we're going to go and leave it like that for now. And now, because I have my unit in grams of NH3, that is my final answer. It's lengthy. It takes up a lot of space on your paper, but that's the idea. This is exactly the same idea that we're going to do with all of the other steps, but the math is going to look differently. But I'm going to change grams of my given to moles of my given, change my substance, and then change my unit. Same idea every time. Okay, so that's one method. Follow the steps. The key idea is to make sure that your units match. And the key step always is this mole ratio, where you're changing one substance into another substance. I am always, always, always going to use that ratio, okay, when I'm using stoichiometry. All right. Same question, but I'm going to do the more traditional method. The more traditional method recognizes those same steps. And remember our steps, or we're taking moles of our given. Oops, I take it back. We start off with grams of the given. So in this case, we're going to take hydrogen. So our steps are going to be, we're going to take grams of hydrogen, turn it to moles of hydrogen, take that and turn that to moles of what I want, in this case NH3, and turn that back into grams of NH3. So again, this is the same process. I'm going to use my periodic table to change from grams to moles. I'm going to use my reaction to change substances, and then I'm going to use my periodic table. The work's going to look a little bit different, but it's the same idea. Okay, again, this is exactly the same question. I'm just showing a different method. So I'm going to start off with my 12.8 grams of hydrogen. Because I know a lot of steps, I'm just going to draw myself a nice long line. Okay. I'm going to change grams of hydrogen into moles of hydrogen using my periodic table. Notice my units cancel. I have moles of hydrogen. So in my head, I know I've done this step. Okay. The second step is going to change moles of hydrogen into moles of ammonia. So I'm going to go up here, and I'm going to take 3 moles of hydrogen, which will turn into 2 moles of ammonia. Again, my units cancel. Now I have my units, I have moles of ammonia, and that's how I change moles of hydrogen into moles of ammonia. My third step is going to be to change moles of ammonia into grams of ammonia. you should recognize that I need to go to the periodic table to find out that there's 17.04 grams of ammonia to every 1 mole of ammonia. So again, my periodic table is how I do that step. And now, because I have the unit that I want, I just need to put this in my calculator. So I'm going to take, I personally like to take everything and go multiply everything across and then divide by everything on the bottom. So I'm going to take 12.8 times 2 times 17.04 divided by 2.02 divided by 3, and I should get the same answer that I got before, which was 71.98 grams of NH3. Now, if you're doing those calculations and you're stopping and you're re-entering your number each time, you're going to have a small rounding error at the end, but your number should be very, very, very close to this. Okay, definitely 72 grams of ammonia is what it should round to. Okay, so method 2, this is the traditional method. I find that a lot of my students are really confused by this method because you have to understand what each step is doing. So really quick, first step, changing grams to moles using my periodic table is what that relationship does for me. Changing moles of hydrogen into moles of NH3 is what that step does for me. And finally, changing moles of ammonia into grams of ammonia is what that step does for me. So that was using the periodic table. This was using my reaction. That's terrible handwriting. I'll rewrite those in a second. And this is using my periodic table. So again, periodic table to reaction to periodic table. But this should not be just follow the steps. This should be understanding the steps. If you understand the steps, there is a way that I find a lot of students really get. It seems like it's easier. It seems like it's fewer steps where we're combining steps. But really, we're doing the same work. We're just kind of doing things so that it looks neater, it looks nicer. Watch. We're going to do the same thing. So we're going to be given 12.8 grams of hydrogen. And again, we're looking for grams of NH3. Same idea. I know that I'm going to start with 12.8 grams of hydrogen, and I need to end up with grams of NH3. So when I look at this and I start to write out, okay, I'm changing substances, and I'm going to use this 3H2 to 2NH3 to change substances. And I recognize that's moles and moles. I go, oh, I can't use this yet because my units, again, don't match. So what do is I make my units match. What every chemistry teacher, and what we've done in the last two was we always made this unit match first. We always change this grams to moles. Well, there's another way. What if I took these moles and I turned those to grams? So I'm going to take this and I'm going to write to myself, oh, let's do this in red. 3 moles of hydrogen are equal to 6.06 grams of hydrogen. Look, 3 moles H2 times 2.02 grams of hydrogen to 1 mole of hydrogen, we're going to get 6.06 grams of hydrogen. So 3 moles of hydrogen are equivalent to 6.06 grams of hydrogen. So to make my units match, I'm going to change that. I'm just going to rewrite that as 6.06 grams of hydrogen. Now, if my unit at this point were to find moles of NH3, this would be my work and I would be done. Notice how my units now match. All I did was I just changed the 3 moles of hydrogen into the same value, but as grams. Now my units cancel. So here I could do my math and I'll have moles of ammonia, but I don't want moles of ammonia. I want grams of ammonia. So I could do this now and then do my periodic table and answer my question there. Or I could take and I could say that 2 moles of NH3 is equal to how many grams of NH3? Well, on the periodic table, 1 mole of NH3 is equal to 17.04 grams of NH3. I do that in my calculator. So I'm going to do 2 times 17.04. And I'm going to get 34.08. So this then becomes 34.08 grams of ammonia, which is the same thing as 2 moles of ammonia. Just like this was the same thing as 3 moles of hydrogen. That is a 3 to 2 mole ratio, but it's not written as a mole ratio. Now it is written as a mass ratio, which is equally valid as long as this mass and that mass are equal to the same. It's equal to that same mole ratio. When I cancel off my units, I'm canceling off grams of hydrogen. I end up with grams of ammonia. I do my work on my calculator, and literally what I'm going to do is 12.8 times 34.08 divided by 6.06. So 12.8 times 34.08 divided by 6.06. And I'm going to get, lo and behold, the same answer. Now, using this method, and using really all of these methods, you have to pay attention to your units. You have to pay attention to your units. That's really what it's all about. It's about using the mole ratio and using the periodic table. The mole ratio changes from one substance to another substance, and the periodic table changes from grams to moles or moles to grams. You just have to use that properly. Okay? Hopefully this makes sense to you. If not, talk to somebody who's understanding the steps. Do not just try and follow the steps. Understand what the steps give you, what they mean, and you'll be successful with any stoichiometry question. There are many other versions of this where we're going to change into milliliters, or we'll change into liters, or we'll change into pressure, or we'll change, but it's always the same. It's using the mole ratio, and it's changing your units to match. That's really the heart of stoichiometry questions. Next will be limiting reacting questions, which are then getting to understanding what the reactions mean and what your calculations mean. But when you got that down, it's not bad. Understand one step at a time. Good luck.